In this lecture, we will have an overview of HVAC control systems, and in the modern day it is quite common that any large air conditioning system will have a sophisticated control system, and we are only going to just have an overview of the elements of a control system, and then we will look at some elaboration of the various concepts that are to be applied when we develop a HVAC refrigeration system. An HVAC control system, which may be a very simple system like a thermostat, or a much more complex computerized control system, will have four basic elements. It will have sensors, controllers, control devices, and there must be some source of energy for the control system. If you look at this block diagram that shows those components of a HVAC control system. For example, the process that we are interested in is room heating, and by using a temperature sensor we can look at the temperature of the room, and what we will do, we will have a desired value which is known as the set point. So let's say we want a temperature inside the room to be 24 degrees C. It is possible that at some time the temperature starts to increase or it drops down, and based on those sorts of variations we want to have a control system that will allow us to maintain that temperature in the room. So what will happen there, the sensor will sense the temperature in the room, and it will send a signal to a comparison device. The comparison device will compare the desired set point value with the value that the sensor has provided, and that will generate a signal. Depending on the difference between the two values, an error signal will be generated, which will be sent to the controller, and then the controller, based on the error signal, will cause an actuator to move. So for example, if the temperature drops, then what will happen? The sensor sends a signal to the comparator and it produces an error signal, and the controller causes the actuator to, for example, increase the rate of the air that is being supplied to the room, and that will again bring up the room temperature to the desired level. And it would be the other way around. If the temperature increases beyond the set point value, we want to reduce the airflow into the room by the same process, and that is how this basic control mechanism would be able to maintain the desired conditions in the controlled space, that is your room. The sensor will as I said, will measure the controlled variable, which could be temperature, or it may be humidity, or the flow rate. And so we can have two types of sensors: analog sensors, which produce a continuous change signal according to the variable which is continuously or may be continuously changing, so it will produce a changing signal as well. Or you can have digital sensors, which provides signals which are discrete, that is on, off, or 0, 1. So those are digital sensors. And in an HVAC system, the typical sensors we come across are temperature measuring devices, humidity measurement devices, pressure, volume, flow rate, air velocity, and also liquid level measuring devices. So these are some common types of sensors you will come across when we look at a HVAC system. The controller functions to receive the inputs from the sensor. It processes the input, and produces that intelligent input signal for the control device. So the output of the controller would be an intelligent signal that will then accordingly control cause the control device to operate. The control device will definitely, as the name implies, will control the variable. So the control device may be a control valve, it could be a damper, it could be the coils for heating and cooling. That means we are controlling the flow rate. It can also control the speed of fans or pumps. So you can have these typical devices or components which are controlled in an HVAC system. The source of energy, we need a source to power the control system, and they can be the sources of energy that can be either pneumatic or electrical power supply. Now in a modern HVAC control system, the control system should fulfill certain objectives, and one of the principal factors is now the energy consumption. So lower energy cost and lower operations cost to have increased flexibility, and definitely assuring the quality inside the conditioned environment. These all objectives are fulfilled by using a proper HVAC system. There are a number of different types of control systems, and we will look at 5 different types and try to bring out the basic differences between these 5 types. One is known as the direct acting type, and that is the simplest type. So you will have a sensing element which will transmit power to a valve or a bellows or a diaphragm through some capillary, and it derives the energy from the process that it is actually trying to control. So we do not have an additional source of power. And a typical example of this is the thermostatic expansion valve, which you have studied, that increase in the superheat at the evaporator outlet causes the refrigerant charge in the sensing bulb of the thermostatic expansion valve causes an increase in the pressure, which is transmitted to the diaphragm, and that diaphragm then causes the movement of the needle arrangement inside the body of the thermostatic expansion valve, causing an increased flow of the refrigerant to the evaporator, and it will work the other way around when the degree of superheat decreases. The second one is an electronic or electrical system, and a simple block diagram of such a system is shown over here. You again have the controller, and we have the sensors, and you will have the actuator. So we have the inputs into the controller. So let's say in this particular case you have the outdoor air temperature, and you also have a sensor for the hot water temperature, and we have a set point over here. So for example, if the air outside, that outside temperature goes down, let's say we are talking about heating, so we are supplying hot water to the heating coil, and air is then passes over that heating coil to be warmed up, and then it will be sent to the room or the conditioned space. So if the outdoor temperature drops, it means there will be a greater heat loss from the conditioned space, and you will need to increase the temperature of the air. And what we can do, that will be done by increasing the supply of the hot water through the heating coil. So these two temperatures, the hot water supply temperature and the outdoor air temperature, so if you have a certain set point and the outdoor temperature drops below that, then what the controller will send a signal to the actuator, and where you have the control device, which is a valve, and that valve will then be allowed to provide a larger flow rate of hot water to the heating coil. So that valve will be operated through an electrical signal, and this is just a simple example of a electric or electronic system. A very common simple electrically operated device is the thermostat, which we find in our domestic refrigerators and air conditioners. But we can also have more complex elements of the HVAC system, which are operated by using electric or electronic control system, and these include solenoid valves, which can serve multiple purposes. They can energize oil burners, or as we looked at, it can increase or decrease the flow rates of the water through various circuits, and it can also control the electric heating if there is any, and they can also operate dampers, and they can turn on fans, pumps and devices like that. An electronic control system can also have a digital readout, and these days it is quite common to have control systems with visual displays. The third type is a pneumatic system, and historically that has enjoyed quite a large or diversified use in HVAC systems. And when we talk about pneumatic systems, we are using a compressed gas, and that is air, and that can be controlled. The pressure of that air can be controlled by the devices that we are looking at, like thermostats and humidistats. So those signals from the thermostats and humidistats will then be used to change the input pressure. And then the device that we are operating will be operated, and they have been again used for various purposes, that is opening valves or dampers and energizing other equipment. So this is again a block diagram of a pneumatically controlled system, in which the compressed air then causes the actuator to function, and then it operates the valve or a damper. The principal advantages of pneumatic air is that, of course, the air is cheap, and it's very durable and safe, especially in hazardous areas where you do not want any possibility of electrical sparks. And it is also capable of modulation, that is, with variation of the variable that you want to control, the compressed air's pressure can also be varied, and that will be quite useful for modulating various components. For example, like a damper, if you are, for example, using a 24-volt electrical control system, that will only have an on and off requirement for the damper. But if you want the damper to be open at intermediate positions, you can use pneumatic controls, and we can have the damper open at various intermediate positions. So this allows greater flexibility in your system, and it provides greater matching with the supply and with the load. Of course, pneumatic systems require that the air that you are using must be processed in the sense that it should be clean and dry and oil free, both as the control medium signal and to drive the various valves which use diaphragms. Next we come to microprocessor systems, and the most commonly used control system in modern day applications is the direct digital control or DDC system, and it requires microprocessors, as the name implies, for handling various inputs and generating a number of outputs, which can then control several different devices at the same time. And we again have a block diagram over here of a DDC control system. You have the conditioned space, you will have various sensors, they will be sending signals to the controller or the controller panel. You will have a user or the operator and machine interface as well, in the form of a display and sort of a keypad alongside. The principal difference between the DDC system and an electronic system is in the handling of the input signals. In electronic control systems, the analog sensor signal is amplified and then compared with the set point, and then we operate the desired component. Whereas in a microprocessor based system, the sensor input is converted to a digital form, and then we have discrete intelligent instructions in the form of algorithms which process the data and generate the desired output. And because these algorithms are quite sophisticated algorithms, we are able to control a very large system and in a very efficient manner. So you can have multiple buildings having a central DDC control system, and that with increasing complexity, the DDC control systems also have the capability to handle that complexity and also fulfill the desired basic objectives of a HVAC control system.